Okay, in this video we're going to look at how compound interest works. So basically when we are looking at saving money, say for example we have a lump sum of €5,000 that we're going to save, and the bank tells us that they're going to give us interest of 3% per annum. Per annum means per year. Now, what that means is that for each year that we save our money, the bank will give us 3% of that figure. If it's compound interest, that means that our figure for year 2, so say for example, we're looking at year 1. All right, so in year 1, we are starting off with €5,000. So that's our start figure. The interest that we earn is 3% of the 5,000. We can do that in our calculator. So if we get 5,000 multiplied by 3%, that gives us €150. Our final value at the end of year 1 is the interest added onto our start figure. So that means we have €5,150 at the end of year 1. And that's how interest works. So the bank give us interest as an incentive to keep our money in the bank account. All right. Then if we were looking at going to year 2, rather than starting at 5,000, we actually start with our new figure of 5,150. And again, we get 3% of 5,150. So 5,150 multiplied by 3%. This time gives us €154.50. Again, our final figure at the end of year 2 is going to give us the combination of those two figures. So we have 5,150 plus €154.50, and that gives us in total €5,304.50. If we leave it in there for a third year, we look at the same process. We're looking at a starting value this time of €5,304.50. We're going to look at getting 3% of this as our interest. So 3% of €5,304.50 is 159. Now this is where we have to round it. So it's 0.135. So that's 0.14 because we always round money to the correct two decimal places. And that gives us a final figure. So we have €5,304.50 at the beginning of the year. By the end of the year, we are adding on €159.14, which gives us a final balance at the end of year 3 of €5,463.64. Now, you can imagine if we had to do this for a number of years, it gets there's quite a lot of work involved. So that's where the compound interest formula comes in as a shortcut. So on page 30 of our log tables, we have the formula F equals P bracket 1 plus I to the power of T. So in this formula, T represents the amount of time that we leave the money in an account for. So if we're looking at this schedule here, we're looking at leaving the account open for 3 years. So T would equal 3. I is the interest rate, and it always has to be written as a decimal, so not a percentage. So what we do is we type the percentage into our calculator with the percentage button, press equals, and that changes it to a decimal for us. P is our principal. That's the very start value at the beginning of year 1, and that's the value given to us in the question. F is what we're looking for. That's the final value. So if we look at what we did here, the breakdown of years 1, 2, and 3, we can actually do that all in one step. So we're looking at the future value or final value is equal to our starting value of €5,000 multiplied by 1 plus 3% as a decimal is 0.03, all to the power of 3. And if we type that into the calculator in one go, that gives us €5,463.64. So we can see we're getting the same figure as what we got when we looked at breaking it down year per year, but it's a bit of a shortcut version. So when we're looking at using compound interest, we always want to make sure that we use the formula. Now, we can be asked for different things. So we'll look at a couple of different types of examples of questions that we can get on compound interest. So our most straightforward one is the question I've just done there, where we're given the starting balance, we're given the interest rate, we're given the time frame, and we're just looking for the final balance. Another type of question is an account gives compound interest of 4% per annum. At the end of 3 years, the amount in the account is €6,500. How much did we start with? So in this question, we are looking for the starting balance. So again, we write out our formula, F equals P bracket 1 plus I to the power of T. In this one, we know what the final value is. At the end of the 3 years, the amount in the account is 6,500, so that's our F. We don't know what our P is. We have 1 plus 0.04, 4% is 0.04 to the power of 3. So what we need to do here is we need to get the P by itself. P is currently multiplied by this bracket. So in order to get rid of that, the opposite to multiplied is divide. So we divide across, so we divide the 6,500 by 1 plus 0.04 to the power of 3, and that gives us a starting figure of, so if we type that into our calculator, that gives us a starting figure, and always give it correct to the nearest cent, €5,778.48. So that's how we look at working backwards. So in this type of question, we are given the final figure and we are asked to work backwards to find the principal. The other type of question we can get is one where the interest rate is missing. So in this type of question, we invest €5,000 for 4 years at R% compound interest, and we have a balance of €5,762 at the end of 4 years. Find R. So this is where our percentage is missing. Again, we start off with the same idea, the same formula, F equals P bracket 1 plus I to the power of T. We fill in what we know. So we know that we have a balance of 5,762 at the end of the 4 years. We are starting off with a figure of 5,000. We don't know what the percentage is, and we are leaving the money in the account for 4 years. So that's what we can fill in at the moment. We want to get the R by itself. The first thing we need to do is get rid of this 5,000 here. 5,000 is multiplied by the bracket, so therefore we bring it across and we divide. So 5,762 divided by 5,000 is 1 plus I to the power, or 1 plus R, sorry, to the power of 4. So if we type that into our calculator, 5,762 divided by 5,000, that gives us 1.1524. Now, the next thing we need to do is get rid of this power. There's a special button on our calculator. It is the button, so it's a yellow function. We have a square, a root, and then an open square. So it's above the x to the power button. It's the second function of that. What we do, we put, because we're looking for the 4th root, we put the 4 on the outside of the square root sign here, and we're looking for the 4th root of 1.1524. So that's what we look at it. So the opposite to the power of 4 is the 4th root, and that gives us 1 plus our interest rate, or R. So if we type this into our calculator here, the 4th root of 1.1524 gives us 1.036098, we'll say that. And normally we'll look at these interest rates correct maybe 3 decimal places. So we could actually leave it there at the 1.036 if we needed. That gives us 1 plus the R. To get the R by itself, all we do is we subtract 1 from both sides. So 1.036 minus our 1, so that leaves us with 0.036. And to turn this into percentage, we have 3.6%. we simply multiply that figure by 100. And that's how we find our missing interest rate. So that's the three main types of questions that we get on compound interest: finding our final value, finding our principal or our starting value, and finding a missing interest rate. Hope that makes sense.